Welcome everyone to the CSK8 podcast. My name is Jared O'Leary, and today I'm going to be unpacking some scholarship. The article that I'm going to be unpacking is titled Creative Coding, Programming for Personal Expression, and it is written by Kylie Peppler and Yasmin Kafai. Apologies if I ever mispronounce any names. All right, so if you look at the show notes on my website, you will actually find the citation for this particular article where you can click on the title and it'll take you to a PDF of the article. And then if you click on either of the author last names, it will take you to the Google Scholar profile so you can actually read more of their materials. All right, so you might be wondering, what is this article about? Let me read for you the abstract. Media arts within primary and secondary education is a relatively new avenue of research. Within the context of the arts classroom, rarely is learning to program emphasized, despite its importance for creative expression in a digital medium. We present outcomes from an extensive field study at a digital studio where the youth accessed programming environments emphasizing graphic, music, and video. Learning the language of creative coding is essential to expression in a digital medium, one with increasing importance for youth and society at large. Here, we argue that it's not just in the viewing or playing of digital media, but also in the constructive or coding experience through which connections to art can be established. End quote. Now, this was written in 2009, so it's been a while, and since then, a lot of people who have talked about creative coding have also just kind of broadened it into creative computing. So whenever I mentioned creative coding from this article, you can think broader towards CS by thinking of creative computing. If I were to kind of distill this entire paper down into a one-sentence summary, I would describe it as an analysis of a single project created in Scratch, which appears to indicate kids can learn how to create media arts expressions despite little experience with coding. All right, so let's dive into the article itself. So Peppler and Kafai begin by pointing out that at the time of their publication, there has been little recognition for a need to program in schools, especially in the arts, where professionals often use, quote, advanced programming to manipulate and create digital expressions, end quote. That was in PDF page 1. So what they're kind of talking about there is that a lot of media artists are using programming to create like animations and stuff. So you may have seen some of the like behind the scenes Pixar videos and whatnot, or like keynotes where they talk about how they used a ton of programming to do the lighting effects or to randomly generate environments and things like that, or like to get the grass to move. So in those media arts creations, there's a lot of programming involved. And so that's kind of what the authors are talking about here, is that those kind of advanced programmings combined CS concepts with visual art concepts or media arts concepts. Now, the authors indicate that previous forms of media arts engagement tend to focus on visual media through static or video images. So think of like creating something in like Photoshop or in a movie editing software. However, Peppler and Kafai actually suggest media arts engagement can include coding as well. Now, when CS is integrated into a traditional classroom, Peppler and Kafai actually suggests that the focus in 2009 tends to revolve around integration with math and science. However, the approach they forward, quote, situates programming within a more media-rich context, focusing less on the manipulation and interaction with numeric symbols, but more on digital media, end quote. And that is also on PDF page 1. So what they're suggesting in this particular article is that rather than learning how to program through numeric symbols and things like that, kids can actually learn how to program by using digital media. Now, back in 2009, when this was written, that was kind of a very novel thing for the most part, just because there wasn't a lot of graphical user interfaces, or at least not as many as there are today. So what they're suggesting is that kids can learn how to program by manipulating sprites and programming each one of them individually to do something, like create a game or a story or a dance or an animation or whatever, rather than just focusing on manipulating variables or numbers. In the intro, Peppler and Kafai point towards research that they might describe as creative coding within domains such as video game design, computational craft and robotics, and within animation and computer graphics. If you're interested in reading more about those, they do highlight some interesting sounding studies. And you can read those citations in the paper itself by going to the show notes. They kind of round out their introduction by saying that by using Scratch, kids can actually learn how to program through media arts by creating video games, art, objects, animated stories, etc. Okay, so you might be wondering, well, how is this study designed? What exactly is going on here? So what they did is they kind of took some ethnographic field notes and collected over 300 design projects over the course of a year. Now, the participants that were in the space that they were at in Los Angeles at a media art studio were ranging from ages 8 through 18, and they tended to either work as individuals or in small groups on a variety of media arts projects. One of the project types that they could work on is programming media arts through Scratch. Now, this particular paper highlights one participant within this space. So here's a quote on the participant. A 13-year-old African-American artist called Kaylee. Although she has over 4 years of experience at the studio, this is her first project using Scratch as an expressive medium, end quote. And that was on page 3, PDF page 3. So Kaylee's project is a dance project that she created over a 3-week period, and she spent between 6 and 7 hours working on it. Now, it's important to note that she didn't have a lot of experience before going into this with programming. Okay, so what were their main findings in this study? So there were 2 main categories of findings that they had. One was personal connections, and then the other was epistemological connections and expressions, which is a mouthful. All right, so let's talk about the personal connections first. So Kaylee made personal connections with the projects by creating a dance project based around a Gwen Stefani song, Hollaback Girl. She also made connections by inserting pictures of herself and her brother in the project. Although this might be considered a personal connection as it is, she repeatedly made comments about whether her appearance matched the style of a music video. So her goal with this project was to create some kind of a music video, and she wanted to be in that, but she didn't just want to have a picture of herself. She wanted to look like she was in the music video. So it was really important for her that her appearance was appropriate and fit within the music video. Now, on the epistemological connections and expressions, here's a quote that they have on page 4. Quote, we find that there was an iterative cycle, starting with a design-oriented goal, i.e. how the characters should look and dance, and achieved by utilizing complex command structures, end quote. Okay, so Kaylee tended to group sprite behavior together by type and gave each group distinct motions to create a music video. So if there were a bunch of dancer sprites, the dancers would all move in different ways. If there were some lighting effects, those would kind of all have different code that were similar to each other, etc. Now, one of the important things that they mention in this particular section, and this is on page 4, is, quote, without any prior programming experience, Kaylee was using looping constructs, repurposing scripts, and moreover, coding creatively, end quote. So that is a very important finding. So some of the educators that I've talked to in CS have mentioned that they're afraid of getting into the creative computing side of things because they feel like they need to lecture on it. First, I need to talk about sequence, and then I'm going to talk about how to loop those sequences, and then I'm going to talk about event handling or variables or whatever. So they assume that you need to have a structured environment for what you're going to do. But in this particular study, they mentioned that Kaylee didn't have a lot of experience, but she actually uncovered a lot of computer science concepts or practices by just creating something, in this case, a music video to Hollaback Girl. On page 5 in the discussion, the authors actually mention the following, quote, learning to creatively code does not necessarily involve an extensive and time-consuming introduction, end quote. Having had experience with all grades K through 8 in coding and makerspace style classes, and then all grades K through graduate and other subject areas, I agree with this. In my experience, it didn't take a lot of time or front loading to get kids to create, especially in a platform like Scratch, which has a lot of tutorials and little mini guides that can kind of just provide a small snippet of information to get going, and then kids are able to kind of run with it because of the experience designed into the platform itself. I.e., the things are grouped in terms of if I want to make something move, I should probably click on the motion tab, etc. So it's a relatively intuitive, albeit fairly complex platform that kids can use. And not only can they use it, but they can use it with little upfront teaching or direct instruction. Now, in their conclusion, they end with the following 2 sentences. This is also on page 5. So, quote, the potential of getting youth interested in technology has not been realized in computer science nor in arts classes, representing a missed opportunity for arts education, especially since many involved in changing in the absence of women and minorities in information technologies have argued for alternative approaches in computer classes to broaden participation. Given this need to become fluent in both the arts and information technologies, it makes sense to offer interdisciplinary experiences for young children, similar to those presented by Scratch, end quote. So what's interesting is like this issue was being raised in 2009, but it's still an issue that we're talking about in computer science education today. We're still talking about how to get underrepresented groups and minorities to participate in classes. Now, having experience working at a nonprofit, I can say that like going for district-wide implementation is one way to try and get everybody involved with coding. However, just doing that alone is not going to be enough because you need to also encourage kids to understand that they have a potential future with this, whether it be in a corporate route or even in a leisure route. So an example of a corporate route would be like, hey, by the end of 12th grade, if you really work hard at this, you'll be able to program and you could potentially get a job right out of high school without even having to get a degree, although a degree might help. Now, a leisurely example is I actually proposed to my wife by modding the game Minecraft. So I went into the game's code and I took the wolf and made a variation of that for each of our dogs so that all 4 of our dogs were in the game because of the code that I used for it and some of the visual mods that I made, etc. So like that was one way that I used code in my leisure. But another example of how I did it is I would create apps for myself and for my friends that we would use to play like Magic the Gathering because we're nerds. All right, so that's kind of like a general summary of some of the main findings that I found relevant and then some side commentary here and there with what was going on. At the end of each one of the podcasts where I unpack scholarship, I want to kind of talk about some of my lingering questions or thoughts. One of my lingering thoughts was that not only could this provide opportunities for arts educators to explore coding in CS, but also for CS educators to explore the arts. So whenever people are engaging in any kind of interdisciplinary collaborations or explorations, I really like for both sides to think through how could each discipline learn from the other rather than kind of positioning one discipline in a subservient relationship to the other, which I think is kind of problematic. Now, I'm not saying that the authors did that. I'm just saying that like whenever I read this interdisciplinary stuff, I really want people to think through how both or all of the disciplines involved can benefit from these kinds of explorations. Now, one of the questions that I have for this particular study is, when does or doesn't the creation of a product or expression demonstrate understanding? So what does that mean? So when they were talking about this product, the music video that Kaylee created, they were analyzing the code itself, and they kind of provided some examples of like Kaylee was really excited when this happened, or Katie was frustrated when Kaylee was frustrated when X, Y, or Z happened. But they didn't really talk about what Kaylee was learning at those moments. They only talked about epistemologies or things like that at the end in relation to the product itself. So a follow-up question that I have is, how much of a creative expression is the result of understanding and how much of it is the result of experimentation and happy accidents? In other words, just because there's a bunch of sequences and loops that are going on in there, it could have just come about by kids dragging in and dropping a bunch of blocks in a sequence and going, oh, that looks cool, but not actually knowing what's going on in that particular sequence. And I say that as having seen kids do that when I would kind of just like be walking around monitoring the class and just checking in formatively to see how kids are doing. I'd see like a really interesting set of code, and then when I dive deeper by asking questions like, oh, so what do you think this is going to do, or how does this work? Sometimes they would just confess like, oh, I don't know, I just kind of dragged random stuff and this is what I got. I think it looks cool. And while I agreed with them, I don't think that kind of an instance demonstrated understanding as much as it just was a happy accident that resulted in a project that kids were happy with. So another question that I have is, so what are some approaches that can be taken along the way to focus on understanding throughout a process rather than assessment of the product itself? So whenever you're in the classroom, what I'd really recommend doing is try and do as much formative assessments as you can throughout the process, where you're just constantly asking questions and trying to get kids to think deeper or share their understandings. This could be one-on-one, or it could be even in the form of like goals at the start of the week. So I saw kids in three-week rotations in my classes, where I'd see them every day of the week except for Wednesdays. And on Mondays, what we'd do is we'd set a goal for the week, and they'd fill it out on a form that it was submitted electronically. And then throughout the week, when I walk by, I'd ask them, how are you doing on your goal? How's what you're working on right now relate to the goal that you submitted to me, etc. And so while I was doing that, it was trying to get them to really understand the processes that they were doing rather than just creating something random or just experimenting on their own. And again, there's nothing wrong with like experimentation and whatnot. I happen to love it. I've learned a lot from it. But when experimenting and it creates some kind of result, I really want kids to kind of like try and figure out how did this series or sequence or algorithm create that happy accident that I'm going for. Right, so those are just kind of some of my general thoughts or questions after having read this study and kind of a summary of the study itself. Again, you can find the show notes to read the entire paper and see a bunch of the other publications by both of the authors just by clicking on their names in the show notes on my website. Speaking of, you can check out the website for more podcasts and a ton of resources. Everything is free, no advertisements, nothing like that on there. The only thing that I ask is that you consider sharing with someone or with a community, or share by simply providing a review of what you thought of this podcast after having listened to some of them. I want to thank you for taking the time to listen to this podcast, and I look forward to releasing more of them.